starts to develop. And the idea is that eventually a person could create what would be fascinating to imagine in space as back to like a some kind of instrument set. In effect, if the fabric itself, of the uniform is electromagnetic field effects where you can control over the volume of the uniform through its thickness, how much field effect should occur. And if energy is sent to it, or if it basically has its own battery store, basically the next layer in the right direction from the core field effect, maybe in the middle. I don't know. You think about it. And the idea is that it itself is a processor. And so it's a field effect. For example, the gamma emissions flying past it can be absorbed based off of the design of the system into either thermal energy or photonic absorption by panels absorbing that gamma energy based off of the change in resistance that occurs to the processing matrix. And so what happens is when that energy is induced into the system, when it's noticed, so it's basically like a set of sunglasses where they reduce exposure, uh, or like maybe sunblock might be a better consideration, where in this effect we chemically unravel the energy, or we just redirect the molecules. And so hopefully it ends up being a device that, like in a raw, has a uniform subset, an actual processing that is your computer. And luckily, this is a semi crystalline pattern. Not completely. You can imagine electroactive polymers, which, when stimulated with electricity, is a uniform change to the amount of resistance in an environment. Like, I'm not even, don't even think about gravity in here. Like, I'm on space to you. You don't even know. So, this is this amount of matter underneath is a sensation of gravity, and that's a perspective warp of factorial divisions of energy structure. And you've got different ranges of how you consider thermal properties in the system. There's very hot spots in a monitor, but it's how you divide the property into a little decimation that helps a person realize that when you see something hot, there's the contact surface area, and that's really important. It's almost like vapor pressure for a surface. And so using those kinds of avenues, you can optically transform using orthogonal subsets down to AC, right? Eventually, you have an AC geometry. Instead of a catalytic converter where you're just looking through it in one direction, well, maybe that's the right kind of implementation. So in that way, it's like a shutter. Maybe you got it at a 45-degree angle. So there is no visible way straight through the uniform. And so at the shutter property of now 45 to the point out direction of the organism within, because you got to bring your friends, then you gotta set that up just right, and so we have divisions of distributed energy that would be basically a way to help the uniform with a certain amplification depending on the material characteristics and what you use to help change the different energy types. For example, quantum dots in monitors are a material substrate that they can add that are very cheap. And so the frequency of the light amplification ends up fluorescing at a different frequency up there. That's going to be something like that, right? And so with that property, you get a change of frequency, which is a temporal still matching subset of speed of light to speed of light, but this is the cable reactions of the gears of photonics. You got to understand that it's like spherical energies that they induce either a spin, if you want to consider it an orbital kind of subset or influence, or at least a linear force, which is like a interconnected set of conveyor belts that point centrically are interconnected. And so we've been looking at different materials. And so I'm thinking either, I don't know, the silicone oxygen, it's Si, so that's silica, right? That's silica, like the silica processors that they use when they're cutting out the features at ASCM and what it was, the other corp, TSEM or something like that? ASM and TSEM? One of them is using this ultra, what is it, the ultra microwave band or ultra IR band, UIR? So they're on a whole nother level over there in Denmark, I believe, right, or Norway? And the place that does a lot with bands, so they understand the pressure bands and what kind of easy implementation strategies can be designed around an O-ring, in essence, right? Because that O-ring substrate has a calculi simplifications. So if it's like a gravitationally true and balanced inside of that system, because gravitationally true is also important. So when you have the strain of a fucking rocket getting lifted off the planet, you got to make sure that that strain is ready on the ship, right? So with the range of that structure being batteries themselves and interconnected through either thermocouples of how the LEDs are interconnected, because we all know that energy or LEDs do release some directional energy. So the system itself, using the idea of uptake and emission, can redirect the energy. So it's got a rudder. So that's how you sail the cosmos, using a fabric density. And there's these cool things you can do with APEC when you match it up with holograms. Because when you have a hologram effect, like a laser beam steered by various principles, like say a film, right? The old school films from optics, those were really an interesting pattern because they could use a laser beam on that surface and it would fill a space, and they would use the principles of the Michelson interferometer. And in my mind, what that was doing, because I don't know the exact detail, but I think I know. See, that's a material composition. That's like setting up a graphene layer at the right temperature, such that when that laser beam was volumetrically filling the cavity using a pattern, like a filter, that was like an image of the space, they had it set up to where they had something maybe in the center of the room. I'll link it in the clip. It'll be down below. It was very cool. You definitely have to see that. That's way better than this video. But in that video, you see this green space filled with just beam describing what used to be there. So it's a 3D image. And it looks like perfect resolution because they could go in and optically change the direction that they were looking through it. And it was like an isometric drawing, being in a video game and seeing that freaking the super small room or something, but in real life with a laser beam, just one freaking beam. And so what's incredible about these, I call it a Micey cube simply because of the property of C. MC Eric Madden right here, right? My initials EM. I'm trying to drive this product, at least support the nations, right? And so I was helping Anthony Areola down there, King of the Hammers. I think that was 2 years ago. I did that for 2 years. I got to put the gas in his rig. You might see that in one of the videos, me filling up in one of the pit stops, because we would pre-run because I got my own buggy, but I can't afford all the costs for getting into the race. And besides, it's freaking dusty. I'd rather run it solos with others, with small groups throughout the long season. That's more of fun behavior for not having that risk of losing a ride that didn't need to be fucking wrecked. That's just me. I'm cheap. And so that's why I'm suggesting this information, because I don't know how to get a loan. So I figure this is kind of like a rough draft of what you can put into a GPT to scan what we've published on Aquachroma to see whether or not that's not just the innovation of uniforms, but that wraps into hulls. And you use the principles of your design experience to build flooring and other substrates to where it's full on environments that aren't susceptible to a lot of the compositions that we were super worried about, like gravitational vortexes, creating pressure fronts that would static the mylar bubbles of a cheaper strategy. Because that mylar stuff is super good, but it could get damaged. And so you have these repair mechanisms. See, because you have the ability to beam steer with that kind of density. You can consider what strata you want to make it out of. For example, WS, you know what that is? Tungsten and the nasty smelling one. And so anyways, have that all interlocking as one type of strata, and it can still induce the changes, but it would be, I think, that much more difficult or less difficult to get to, say, like a superconduction level, because you can use over probably any of these processing universal processor type uniforms. You can use the principles of phase change to store electrical potential. So if you use those electroactive polymers and you have small nodes that can move around in suspension, then you've got various patterns where the fucking David and Goliath thing that was set up to, that was that throw from back in Arc 8 or whatever, that generation. I was like, yo, y'all need to do this strategy. Archimedes, right? He sent that back. That's the smell of the sulfur right there. That's what, it was both intertwined in that bubble. And so sending that off into the ethers, you got the imagination now of energy directionality using those Micey cube principles, and the amount of, CRT monitor technology, that was a linear accelerator using just mirrors and oscillation. So we know oscillation in materials really, really well. So using those little pieces of mylar, you can in effect increase the amount of data sent by having those repeating patterns in orbital trajectories, creating a super light steering mechanism. And so if you want to change to a different strategy, you could have, a variety of things for a polished surface, from graphene and using that kind of strata in various formats, like the graphene sheets on the edges of actual thick couples, because a thick couple in quantum is, well, it has the potential of faster than speed of light transfer of energy. So it has a phonon cheat. And so if you supercool it, like what we should be doing for energy distribution between cities, that handles both the utility front because you've got a superconduction communications channel. So then what you use is a temporal leashing effect using the speed of light and measuring in a computational checksum with the internet to distribute that information back in, basically the foundations of survey, just another way of camera operating from the spacecraft itself. The hull of these uniforms and the vessels for the communities within end up being the way the world can intercommunicate such a high degree of security, you know, using directional energy, that it becomes the inspiration is now yours to continue that thought process. I'll just call that good. Oh, gotta do more sets.